Hello, darlings. It's me. It's 300 million volts of shocking the system with new kinds of earworms. You'll see what I did there in a second. Yeah, it's Mimi, and I'm really stoked to be with you guys today because, as usual, I have a little something different to offer. Many of you have requested that we cover the topic of jumping worms. And if you're not a jumping worm expert, I suggest that you go to the interwebs and do a quick Google search will will take you to some videos where you can see how these little guys are really something different from what we are used to seeing in the worm world. And today we're going to have a new look at the worm world, which we're also deep in, but I don't know that we necessarily think about it all the time in the way that we're going to think about it today. So today we have Dr. Lee Frelich. Dr. Frelich is a very fascinating individual, and I have been sort of following his work since I was a graduate student in forestry. And he is going to give us some perspective on all things jumping worm. Dr. Frelich is at the Forest Ecology and Landscape Ecology Center on the St. Paul campus at the University of Minnesota Center for Forest Ecology. He has written many papers. He's widely cited in all topics related to disturbance ecology and forest ecosystems, succession of forest ecosystems. He's a leading researcher in those topics and has, as part of that research, gotten very close to several different invasive species or introduced species. We call them invasive. There's all kinds of ways that this episode today is maybe going to be somewhat touchy and polarizing, but it's a fascinating look at some of these organisms that we see every day, don't necessarily think about every day. And I hope you enjoy it. I certainly did. And I'll see you on the other side.
Today's episode of the No-Till Market Garden Podcast is brought to you by BCS America. BCS two-wheel tractors are designed and built in Italy, where small-scale farming has been a way of life for generations. Discover the beauty of BCS on your farm with PTO-driven implements for soil working, shredding cover crops, spreading compost, mowing under fences, clearing snow, and much more, all powered by a single gear-driven machine that's tailored to the size and scale of your operation. We have been using a BCS tractor on our farm since 2014, and it has saved the day and leveled the workload more times than I can count. And I find new ways to employ it every single season. To learn more, view sale pricing, or locate your nearest dealer, visit bcsamerica.com. That's bcsamerica.com. To learn more, view sale pricing, or locate your nearest dealer, visit bcsamerica.com. That's bcsamerica.com. And while you're there, select tractors and attachments on sale through the end of this year. Today's episode is also brought to you by Certified Naturally Grown. At the heart of sustainable ag is the belief that soil health and thriving ecosystems grow the very best food. Certified Naturally Grown is a grassroots certification program that recognizes direct market farmers using holistic methods and shows your customers that the products you bring to market are grown to the highest ecological standards. If you're looking for an affordable certification option that focuses on the thriving of local farms and foodways, you're going to want to check out CNG. Their peer-to-peer inspections create opportunities for farmers to connect, exchange knowledge, and build regional support between growers. Certify your produce, flowers, livestock, apiary, aquaponics, or mushroom operation today. Find out more at cngfarming.org. That's cngfarming.org. All right, enjoy the show.
Well, Dr. Frelich, it's very nice to have you on the podcast today. Thank you so much for making the time to join me.
Sure, you're welcome.
If you wouldn't mind just introducing yourself a little bit to our listeners and telling us about your background and your work and anything else you'd like to share.
Okay, well, I am the director of the University of Minnesota Center for Forest Ecology. I've been studying forest disturbances for several decades, forest fires, windstorms, climate change, and more recently, 20 years still, earthworm invasion. Anything that's a disaster for the forest is something that I study. So I've been studying the European earthworm invasion for, since 1998 or 99. And in the last 4 years, we've started studying the jumping worm invasion, which we're calling the second wave, because they're coming in on top of the European worms that got here a century ago. So, so I have published lots and lots of papers about forest fires and windstorms. I've learned how to detect windstorms hundreds of years ago from tree rings and fires from fire scars, and looking at how that changes succession and all sorts of things. So now I'm trying to integrate all these different disturbances, the changing climate, the fires, the windstorms, which are increasing in frequency, and now the worms, and then the invasive species that the worms facilitate, all sorts of invasive plants. So it's been an interesting career.
Indeed. And I found your work when I was in graduate school in forest ecology, and it's a happy coincidence that you are also working on this species that has suddenly become important to a lot of our listeners, the jumping worm. But I think it would be really great if you could talk a little bit about the European earthworm, because I think a lot of people still don't really understand that is that was an original invader, if you will, and the implications for different ecosystems that you've looked at over time, and then we can get into the jumping worm.
Okay, yeah, the European earthworms came with European settlers, so in the eastern United States, it could have been 200 or more years ago. In the Midwest here, it's more like 100 years ago that they came and first were established in cities. And then because they're used as fishing bait, they got moved out to remote areas. And it's actually a whole suite of species. It's not unusual to have 8 or 10 species of European earthworms in agricultural fields or in forests throughout New England and the Midwest and the southern United States. And they're even moving into some places in the western U.S. They're not quite as invasive in the Great Plains and Rocky Mountains and desert areas because they have dry summers. But any place where it's moist in the summer, so Pacific Northwest, southern United States, Midwest, and New England, they're pretty pervasive across the landscape. And so basically, we've learned the most about their invasion by finding remote areas that still have invading fronts. So you can compare a place that's very similar in soils. The parent materials of the soil and the vegetation cover is the same, but the invading front is the only difference. So we've done that quite extensively, and we found there are stages of invasion. First, there are what we call epigeic earthworms, and Dendrobana is the genus. They're little tiny worms. They are epigeic because they live in the leaf litter and not in the actual mineral soil. And they move very fast. So they are usually the first ones to invade, and they don't really change the ecosystem very much. They just forage for fungi and other things within the leaf litter layer. And then what comes next are the endogeic worms, which are the ones that live in the soil. And then they actually, they're called angleworms. They actually compact the soil. People think earthworms will decompact the soil. Well, they might do that in Europe, but earthworms don't have the same impact on ecosystems as an invasive species in a different continent as they have in their native habitat. And that's true of just about all invasive species, plants, animals, whatever. They do something different as an invasive on a different continent. So they compact the soil, they cause nutrients to leach out, nitrogen, phosphorus, potassium, calcium, important nutrients to leach out. And then there's one species that's what we call epiendozoic, so it kind of lives in the leaf litter and in the top of the mineral soil, Lumbricus rubellus, and it actually eats the organic horizon, which is the accumulation of leaf litter, which can be decades old. And so you have fresh leaves on top and that just fell the last year or two, and then fragmented leaves that are in various stages of decay. And then finally a layer of black humus, which is made out of leaves that might have fallen decades ago. So it makes an organic horizon. It used to be like as thick as a mattress in forests in the northern part of the United States. And when you walk around in those areas, it's like walking on a memory foam mattress, areas where the earthworms are absent. So this species, Lumbricus rubellus, which is a relative of the nightcrawler, Lumbricus terrestris, it's half the size. People think it's a baby nightcrawler, but it's a different species. It actually eats that old organic matter that could be 10, 20 years old. And then the forest floor is gone. And with the combination of the compaction, which conducts heat much better than uncompacted soil in the absence of the insulation of the leaf litter, the soil gets warmer and drier. And as I said, nutrient poor. And then the nightcrawler comes in. It's the slowest moving. It has the slowest life cycle. It's the last one to come in at what we call stage 5 of invasion. So we've gone from stage 1 with no worms to 2 with Dendrobana, and stage 3 with the endozoic, the ones that live in the soil, and then the epiendozoic, and now at stage 5 we have the nightcrawler, and it eats all the new leaves that fall each year. It's finicky because it'll only eat freshly fallen leaves from the previous October. And so it maintains a leaf litter-free forest floor indefinitely, as far as we can tell. So that means the soil stays warmer and drier and more nutrient poor on a permanent basis. And we can even tell from tree ring analysis when they invaded. When those endozoic worms get there and compact the soil and the nutrients leach out, and the epiendozoic Lumbricus rubellus kind of comes at the same time and eats the leaf litter, that kind of all happens within a few years in any given spot. The soil suddenly becomes drier, more compacted, more nutrient poor, and the trees respond. They're more drought sensitive after that. And you see a different pattern in the ups and downs of the tree rings in response to changing rainfall patterns. And we've been able to compare it with adjacent forests that weren't invaded. And they continue to have the same pattern that we had for hundreds or thousands of years previously. Wow. So it's a big change to the ecosystem. The trees grow less, about 30% less for sugar maple, for example. A lot of the species that live on the forest floor, species of plants of which there are hundreds, are wiped out when the worms invade because they were rooted in the organic horizon, which disappears. And a lot of them actually can grow afterwards, but there's no seed source. The standing crop was wiped out. So there are very much fewer plant species afterwards. And so you have a whole different ecosystem, really. And the worms reach much higher abundances than they do in their native continent. So it's a much bigger impact. And so they also facilitate other invasive species, especially plants like buckthorn, Japanese barberry, garlic mustard. There's a whole bunch of invasive plants that germinate on bare soil.
Right.
And they're co-evolved to the worms on their home continent. So they kind of start what we call an invasion meltdown. In fact, night crawlers keeping the forest floor bare, leading to buckthorn. And then you get the soybean aphid, which is a problem for farmers, which overwinters on buckthorn. And the soybean aphid is also invasive from another continent. So it overwinters on buckthorn, and the soybean aphid is the food source for Japanese lady beetles, which gather on people's houses in the fall, especially on the south side of the house. And some people are allergic to those. So you have an invasional meltdown of one invasive species after another, leading to problems for crop productivity, forest productivity, pests for humans, and even allergies for humans. So that's, and then there's concern for some of the plant species, some of the native plants that are quite rare. Some of the orchid species are affected very negatively. And some of the smaller ferns are also dependent on that organic horizon, which is now gone. So lots of issues. The nutrients, of course, go into the groundwater and eventually make their way into surface water. So you can raise nutrient levels in the water, which is a bad thing. It's eutrophication of the water. So it's really a transformation of the whole ecosystem.
Yeah.
Yeah.
You can imagine that this, even though I think a lot of people are aware that earthworms, this sort of broad category that we use to refer to many species, a lot of people are aware that they aren't originally from here. But I think this information that you've just shared, you can imagine it being sort of mind-blowing, life-changing for a lot of people who assume them to be benign, especially when it comes to an agricultural system. And so let's introduce the jumping worm now, because we're getting into a totally new level of extreme behavior, and then we can start talking about all of these things together. But it'd be great if you could introduce us to the jumping worm.
Okay, so jumping worms are from Asia. Most of them are in the genus Amynthus, and it's also several species. There are other genera, but they're mostly Amynthus, and they are epiendogic, which means they live in the leaf litter in the very top part of the mineral soil, which is very important. They don't go deep. They can't tolerate the low oxygen conditions that the European earthworms can, the ones that go deep into the soil. So they're stuck in that top layer. They, unlike the Europeans, which are perennial, most of the Amynthus species are annuals. So they hatch in the spring, they get mature by midsummer, and they die in the fall, whenever it gets below freezing. And they turn the top layer of soil into granules that are like cat litter or coffee grounds, and they are loose granules. They're not firmly attached to each other, so they actually decompact that top layer of soil, and that loose soil becomes an insulator, and it makes the soils cool again. So they basically reduce the soil temperatures about the same amount that the European earthworms increase the soil temperature. However, those loose granules are subject to erosion, and they have a different pattern of eating the leaf litter because they hatch in the spring. They aren't big enough to eat leaf litter until midsummer. So you have last year's leaf litter staying there until late June or July, whereas the European earthworms are eating the leaf litter in April and May. So that's a difference. So the leaf litter is insulating the ground for part of the summer, and then those granules have air spaces between them, so they're good insulators. They're another negative filter on the success of native plant species. Because the soil is so loose, it's just a pile of granules. Some species have trouble germinating because the soil isn't stable enough for a really tiny germinating plant to get established. It looks like if you plant a bigger plant that you buy in the nursery, and I've done this, a lot of them actually will grow in the presence of jumping worms, but reproduction by seed can be a problem for plants when you get jumping worms. And so they don't move around as fishing bait, so they're not going directly to remote areas as much as the European worms. They are moved more in mulch and nursery stock.
Okay.
And they really love mulch. I mean, if you have a mulched garden bed and there are any jumping worms in the neighborhood, they are going to find your mulched garden bed. And we're not exactly sure how they do that, but we know that if you're in a neighborhood that has any jumping worms at all and you put down a fresh layer of mulch, they will find it within a few weeks.
Wow.
And they will multiply rapidly right underneath that mulch. They just love mulch because it stabilizes the temperature at the surface of the soil, and they can't go down deep like the European worms if you get a heat wave. The European worms can just go down a foot or two and wait till the heat wave is over, because down a foot or two, the temperature is way more stable than at the surface. So they can just go down at midsummer, come back up in August or September when it cools again. The jumping worms can't do that. So they really prefer mulched gardens. They also like north and east facing slopes because they stay cool all summer. But that varies among species. I mean, Amynthus gracilis has a much wider temperature tolerance, and it can live in open mowed grass, for example, whereas Amynthus agrestis, which is the most commonly found jumping worm, avoids mowed grass, open, sunny mowed grass, and it's going to stay in mulched garden beds in shaded areas under trees, north and east slopes, because if it gets up to 85 degrees, it dies. And does the top inch or two of soil in an open, sunny lawn get up to 85 degrees at midsummer? Well, yes, it does. And they can't go deep to get away from that like the Europeans. If you have an irrigated lawn, you're watering it every day, that might keep it cool enough that they can live in a lawn. But they're very temperature selective. Mm-hmm. And the mulch, of course, they love that because it stabilizes the temperature. And they want to be right at the boundary between the mulch and the mineral soil. So they are currently spreading. They're in most of the states in the eastern United States now. And what we're worried is that people will take nursery materials and mulch from the city to their cabins in rural areas, and that they'll end up spreading eventually into remote areas like the European earthworms did a few decades ago when they started to be used on a widespread basis as fishing bait. The Amynthus are a little harder to get on a hook if you're fishing because they're they're so active. But we are worried that they'll be widely dispersed because people have so many cabins and second homes, summer houses out in remote areas. Mm-hmm. So that's how they would get there, is taking plants from the city or mulch from the city to your garden in rural areas. And they are spreading in some farms as well. I mean, the European earthworms are widely established on farms, and the jumping worms are just starting to get there now.
So do we know how they got here?
We think that people ordered them on the internet in order to turn like leaf litter and so on into compost. Mm-hmm. And so they got introduced in cities that way, and then got into the being spread along with mulch, although now most commercial mulch producers now heat treat the mulch. And that's not only for jumping worms, it's for a lot of pests that could be spread in mulch. And most commercially produced, overwhelmingly huge majority of it is clean when it's bagged. But the thing is, does it get recontaminated? If it's sitting in a pile at a garden center, or the bags are stacked up and there happens to be a tear in the bag, will the jumping worms go in there? And we have found jumping worms in bagged mulch, and we don't think it's because it was contaminated when it came from the production facility. We think it's recontamination. And then, of course, it goes to wherever people use mulch all over the place. City mulch piles are a problem, where people from thousands of houses bring all their leaf litter to one big pile, and then that's made into compost and distributed to thousands of other houses. So in Minneapolis, we essentially have jumping worms almost everywhere where that's suitable for them. And this has happened in the last 10 years, that they went from isolated occurrences to basically predictably being in every spot that has the right environmental conditions, like a mulch garden bed or the north or east facing slopes, or north or east facing sides of a building, or slopes that stay cooler, shaded areas, irrigated areas. Yeah, I think they're everywhere now in the Twin Cities metro area, and probably other metro areas as well. But there just doesn't happen to be an earthworm researcher in every metro area, so people just don't know about it. But we know they're in Milwaukee and Madison. We know they're in the big metro areas in New England. They're probably in Chicago. They're probably in all the metro areas in the eastern half of the United States. It's just a matter of whether they're being reported or not.
So, in agriculture, especially, compost is such a big part, especially organic agriculture and no-till agriculture is such a big part of how we sort of replenish soil organic matter. And we are sort of, I think, trained, if not, specifically trained, I think we absorb over time this idea that the conversion of mulches and biomass to organic matter by these organisms that eat it and, excrete it out, that's a positive contribution. And it would be really interesting, I think, for you to comment on that, speak to how you think we should consider how these implications, especially because if you think about the European earthworm and how long that's been here, and the implications for not just forest ecosystems, but prairie ecosystems, et cetera, even the capacity for soil biomes to retain not just, nutrients like nitrogen and phosphorus, but even carbon. Could you speak to some of that, and then maybe reflect on, obviously, this is a thing that's here now, and how should we be thinking about it? And what do you have any reflections on, as a person who wants to be the most benign force on the land, how we should be thinking about these organisms and living with them? Or
yeah, sure. Yeah, I mean, they can actually do good things in agricultural fields, especially the European earthworms, and we have a mostly European agricultural tradition in terms of our agricultural practices. And so they actually can improve the productivity of crops. Night crawlers, for example, can cause water infiltration deeper in the soil so that it can be kind of stored up during rainy periods and have less runoff. In places like cornfields, the problem is that night crawlers don't like to be disked and cut in half. and they also eat leaf litter. So farmers that till the soil every year and take all the leaf litter off and have this bare soil, well, they disturb the soil and break up the burrows. And night crawlers have permanent burrows they use for their whole life. They probably injure the worms in the tilling process. They break up their burrows. They take away their main food source, and then they apply all sorts of insecticides and fungicides. And the outer skin of an earthworm is mucous membrane, just like you have in your mouth. And that is the outside of an earthworm. And they will absorb fungicides and insecticides, and it's poison them. So they break up their home, they injure them, they take away their food and poison them. And then they wonder why they don't get a lot of night crawlers in their field. However, if you go to a no-till system, the night crawlers will love it, and they will gradually come out from the hedgerows or the nearby woodlands and spread out into the field, because they really like no-till systems, especially if they have a litter cover, because that's just a pile of food that's always available for them. So that's a whole different story. But in the tilled fields, you get just the Aporectidea, which are the endogeic ones, the so-called angleworms, the ones that compact the soil, which is exactly the opposite of what you want. So no-till will bring in the night crawlers, which is great for the function of agricultural fields. It's probably never going to be good for the function of forests. And we just have to live with the fact that they can be good for agricultural settings and garden settings, especially if you're growing European plants, which most gardeners are. If you're trying to grow native woodland wildflowers in your garden, it's going to be a bad thing for those plants because they are not co-evolved with earthworms, at least the North American native plants. So yeah, it's going to vary in different places. We know very little about the impacts of earthworms in prairies. There's been hardly any research. It doesn't seem to be as big of an impact as it is in forests because prairie plants have very deep roots and they are not as dependent on that litter layer because prairie fires commonly burn that away over thousands of years. So we don't think the impacts are anywhere near as big in grasslands as they are in forests, but there isn't a lot of research. And we know they can do good things in agricultural fields, especially no-till fields, in terms of retaining nutrients, allowing more water infiltration by having night crawlers be the dominant species instead of angleworms, which harden the soil, cause more runoff, and cause leaching of nutrients. Now you throw in the jumping worms, and the jumping worms, unfortunately, caused the local extinction of night crawlers. So the two cannot get along with each other. So we have several invading fronts of places that have had for the last century European worms, and the nightcrawler is the dominant species. And what we're finding is within a few years after the jumping worms arrive, the nightcrawlers disappear. Apparently they're competing for exactly the same food source, and the jumping worms are more aggressive. You know, the name Amynthus agrestus is a good name.
It really is. Such a disturbing. We don't have them out here, as far as I know. I haven't seen them on the West Coast, but I've seen a lot of videos, and you wouldn't mistake, at least behaviorally, you wouldn't mistake it for any of our historically present worms. It's very upsetting to see how they.
Yeah, but I don't know how they'll interact with farm fields other than the night crawlers will disappear. You'll get 2 or 3 inches of these granules. The leaf litter will stay on for a few months in the spring before they eat it. That could be a good thing in that it would cool the soil. And in a lot of places, having the soil be slightly cooler is a good thing in agriculture. But there aren't a lot of studies of the impact of jumping worms on agriculture yet either. So, but certain types of seedlings, if you're planting your crops by seed, would probably do very poorly because they wouldn't be able to deal with the shifting nature of the soil. If you're planting larger plants, it might help improve it by cooling the soil, having less evaporation. We don't know what they're going to do to leaching of nutrients yet. So, a lot of changes that for the jumping worms, we don't have a complete story about how they change things and how they affect different ecosystems yet. But my guess is if you're planting, like root vegetables and you're actually sticking the root in, or planting plants, that a lot of them will turn out to get along okay with jumping worms. Whereas with seeds, you never know whether they're going to be able to tolerate that. If you have a flat site and you don't walk around in it too much, I've discovered just with my own personal native woodland wildflower garden, which is actually on public land next to my condo in downtown Minneapolis. And people thought I was crazy to establish this native plant garden there. I mean, we have 30 and 40-story buildings all around and, very high density downtown core. And yet the north side of my condo building, there was this area where nothing would grow because the shade was too dark. And I brought in native woodland plants. And because it's a flat site, and I put just a small fence, like 18 inches high, so people and dogs, people walking their dogs, don't walk through. And a lot of the plant species are doing very well. And but if you have a slope or you have people or animals walking through, it's just going to upset the seedlings at the germination phase, and they just won't do well. But as long as you can keep the soil stable, I think you can live with the jumping worms.
Today's episode is brought to you by Rimmel Greenhouses.
Whether it's tomatoes to market, flowers in the spring, or your family's harvest, growing in a greenhouse protected from the weather provides the right environment that you need for a harvest that you can count on. Rimmel Greenhouses are designed for durability and offer the quality that you need to grow productively year-round. Visit rimmelgreenhouses.com to get a quote today.
If I may editorialize for a second, I own a Rimmel tunnel. I love it. We built it ourselves, and I really appreciated the quality of the tunnel as well as the customer service we received in the process. So make sure to check them out. Today's episode is also brought to you by Johnny's Selected Seeds. Johnny's Selected Seeds is a proud sponsor of the No-Till Market Garden podcast. Since 1973, Johnny's has supported farmers and gardeners with superior seeds, tools, and information to help ensure their growing success and help feed their communities and families. The research farm is at the heart of Johnny's, where they trial thousands of varieties and tools every year. Their breeding program uniquely focuses on introducing varieties that meet the needs or solve the challenges mixed market, small farmers, and avid gardeners face. Visit johnnyseeds.com for innovative new varieties and time-tested favorites to grow this season. You can also browse their online growers library, link in the description, for a wealth of free educational resources. The employee owners at Johnny's look forward to growing with you. All right, back to the show.
So people who live in an area, farmers especially, who live in an area where jumping worms have become an issue, if they were going to take a sort of cautious approach, are there any practices that you think people should be aware of practicing? Should they be letting people know if they see jumping worms? I mean, what are the sort of best management practices that you have identified so far?
Yeah, well, I think they should definitely let people know. For one thing, if it's a agricultural field, we don't have any research yet. It might be a good research site. And it's good for adjoining landowners to know that they're in the area. So So we don't know what they're going to do. Maybe they will live in the no-till fields because there's litter there. And maybe the leaf litter, if it has any structural integrity, will hold it from soil erosion. I wouldn't think that would be the case on really steep slopes. They might find south slopes too hot. So we just don't know yet what they're going to do in agricultural fields. So irrigation would definitely help them. They like it to be constantly wet. One thing we found is that if you have a gradually developing drought, they gather onto the roots of the plants and they can actually cause massive mortality of plants under certain conditions. But that's only if you have a gradually developing drought and they progressively gather onto the roots of the plants and start eating the root hairs because there's nothing moist and nothing available anywhere else that they want to eat in that type of a situation. If you have irrigation in a flat site, you might very well be able to live with them, and they might even help certain plants, but we don't know which ones yet.
So you think this is an area of agricultural research that might, have some future outcomes that we can follow.
Yeah. And if you're worried about being a dispersal agent, because they've invaded your land, you can try to contain them. So just removing the mulch, the soil might get too hot and they might all die. I've seen that happen. I've seen a few people have success that way. We even did that on part of our gardens in downtown Minneapolis. We just removed the mulch during a heat wave in the summer, and a couple of weeks of that hot soil was enough to do them in. And we have field trials underway with a bunch of different chemicals. We like to think environmentally friendly chemicals, things like diatomaceous earth. And we're also trying saponins, which are secondary compounds that are in leaves. Saponins are in tea. Mm-hmm. And in the processing of tea for human consumption, there's a lot of leftover saponin. And so that's been mixed with fertilizer and sold to be used in situations where you want to control earthworms and fertilize at the same time. It's not officially labeled for that yet in the United States, but some golf course managers are using it anyway to keep earthworms off the putting greens. You can't have any type of earthworm on putting greens because they're going to make little piles of castings and it'll be uneven and the ball won't roll straight.
Gotta protect those putting greens.
Yeah. So golf course managers probably know more about controlling the local populations of earthworms than anybody else. Some of them have actually excavated the soil and put in a couple feet of coarse sand. And a lot of earthworms don't like that, especially if it's sand that has sharp edges. Mm-hmm. And no earthworm is going to like that. It's like a million little tiny razor blades in the soil. And some are using saponins, which are very environmentally friendly. People actually take saponins as a health food supplement. Yeah. We don't know if it's going to damage any other soil biota yet, but that's one of several things we're trying. So I think within a few years, we'll know how to locally control earthworms. I'm not sure we'd want to go out with saponins and treat an entire forest.
Right.
It wouldn't be feasible, and we wouldn't know what else we would kill that might be necessary for ecosystem function. And the same is true doing it on a large scale in agricultural fields. So it's a very new area of research. And our plots at the University of Minnesota Arboretum are about 12 feet in diameter, round plots. And we have several replicates of each of several different trials, one of which is just removing all the leaf litter, and one of which is not watering during droughts, and one of which is watering during dry periods, and one of which is saponins, and then we have diatomaceous earth, and we also have a treatment to make the soil more acidic with sulfur granules. So it's going to be at least another year before we have any results. There's also a research project to look at using those things in the potted nursery stock. If you have an infested nursery, will you be able to get rid of jumping worms in nursery stock that you're planning to sell? Because nurseries are so well irrigated, we're finding just massive populations of jumping worms, like under the beds where things are being grown, because they're mulched and they're watered every day. Yeah. And you just peel back the mulch and you can literally just grab a handful of worms. And so a lot of nurseries are very heavily infested. And the question is, how do they make it jumping worm free at the point that it goes out to be sold to somebody? So there's a research project on that going on at the University of Minnesota Landscape Arboretum in their own nursery. And again, it'll be a few years before we have the results on that. I mean, I suspect the saponins will work really well and end up being the friendliest, least damaging thing, but let's wait until we get the actual data for that. And European worms are everywhere, so we're not worried about spreading them around because it's too late.
Right. And is there anything that, like, are birds successful at keeping populations down where there are good populations still of songbirds and other, sort of predators?
Yeah, I mean, birds, and not only birds, but salamanders and moles and shrews. Actually, we're finding wild turkeys that are eating they'll eat European worms and jumping worms. All of these things are eating all earthworms. The problem is the earthworms can reproduce faster than they're being eaten. Mm-hmm. And for the jumping worms, for the turkeys and other animals, they actually dig through that loose granular soil, thereby disrupting any seedlings of plants that could otherwise be established. So they are reducing the jumping worm population, but not eliminating it, because there's a lot of eggs in the soil that are going to continue to hatch, and then they're damaging the ability of the ecosystem to heal itself by having new plants germinate. Mm-hmm. So it's one of those complex situations with lots of pluses and minuses. And I don't know of any situation where some sort of a predator has been able to totally control earthworms. Yeah. So they're just so good at reproducing, and their eggs are well hidden in the soil. The eggs are so small, nothing is interested in eating them, and they're very prolific in the number of eggs that are laid in the soil. So there's always going to be more hatchlings. Yeah. So I just don't think that's going to work. And earthworms over hundreds of millions of years have evolved to reproduce faster than they're preyed on. This has been an issue for them, and they've responded on an evolutionary scale to coexist with predators.
Do you think, can you speak to the success of these invading worms in our forest ecosystems, and why it wouldn't have been problematic where they came from? I mean, this is the part of evolutionary biology that, when you think about the impacts of an introduced species, it's not that it recognizes that it's been placed in this new, it's just doing what it's always done and taking advantage of every opportunity. So can you speak to how our forest biomes are different, and why the impacts are so different when we have a new species like the European worms and the new jumping worms?
Yeah, well, they're part of the United States. The Pacific Northwest and the Southeastern United States does have some native earthworm species, but they're not super abundant. They're not very aggressive. And then the Northeastern United States and part of the Western United States didn't have any native earthworms at all. So in either case, bringing in earthworm species from another continent is going to cause big changes. Like the native earthworms in the Southeastern United States don't cause the absence of an organic horizon in the forest. It's more like they're using the organic horizon as habitat. And so when you bring earthworms in that are a different species than the native species, they're going to do something different to the soil than the native species. And the soil is so fundamental to ecosystem function and productivity of the whole system, it's going to cause major change. And that's even more true where there were no native earthworms at all. So the decomposition rates were very slow, and basically bringing in the European earthworms was like stepping on the gas pedal for the rate of decomposition of organic matter, to the point where instead of accumulating to a thick layer over several decades, it basically accelerates it to an annual cycle where it all decays within a year. So that's a whole different ecosystem dynamic in terms of the nutrient cycling. The species are not adapted to grab the nutrients fast enough, like they would be in a place where these worms are native. And then there's the fact that they're way more abundant here than they are in their native habitat. So the impacts are going to be bigger. And that's what we don't understand.
Why? I mean,
we don't really know what limits their density in their native habitat.
Because it's interesting, you think about, the place in Europe where a lot of those introduced worm species came from, and the conditions, at least, when I've been over there and digging around in the soil, the conditions aren't really that different. And what is it that's keeping those populations at a reasonable level? Do you have any working theories?
Yeah, well, we have several theories. Maybe there's more saponins in the leaves of those species, and that keeps the earthworm densities lower. Maybe there are more parasitic nematodes that are parasitic on earthworms. Maybe there are viruses or fungi or bacteria that are diseases that limit them. And maybe there are other secondary compounds other than saponins in the leaves or in the root exudates of the native plants there that keep the earthworms at a lower density. And as the system all co-evolved, all these things co-evolved over millions of years, the earthworms were integrated into the ecosystem function in a positive way. And then you bring them to a new continent, their population explodes. There's no adaptation to their presence. They're doing different things to the soil, even if native worms are there. And how long is it going to take for our forest ecosystems to respond to that? And the answer is it's going to be on an evolutionary time scale, so at least centuries. I mean, they will eventually adapt, but not in a human lifetime.
Totally. And I think one of the things that I think about a lot in terms of worms, at the impact of worms, especially in our forests, that farmers should be concerned about is that, our farm fields, while they might benefit in a very sort of timestamp specific way from the conversion of mulch to, immediately usable organic matter, the dehydration of our forests, our surrounding forests and the ecosystems that sort of hydrologically plumb the entire landscape, that the diminishing, kind of growth rate, the diminishing transpiration rates, everything about how a forest grows and contributes to climate is relevant to agriculture. And, you can imagine that forests drying out, those species may actually, produce under drought stress more secondary plant metabolites that will help them defend their litter from worms. But like you say, over an evolutionary time scale. So are there things that aren't, I guess, are there things that we can look to in nature that would help us support those systems better, as opposed to like thinking we're going to get rid of these things, which I think we have proven historically not to be super good at. Are there ways that we can support these systems that support us better?
Yeah. Unfortunately, not something that most people would like. We've discovered actually that deer increase invasive earthworm populations. And they probably do that by eating plant material, and then their droppings in their urine are a more palatable form for the worms. And they might also, just by walking around, fragment the leaf litter more and make it easier for the worms to eat. So probably if we reduce deer populations back to the level that forests evolved with, instead of the super high level that we have now, that would probably reduce the impact of the earthworms. And there's this thing going on with deer and earthworms where the deer increase earthworm abundance. And one of my PhD students, Sam Reed, just published a paper in Ecology about this a couple months ago, using actual experimental data where deer were fenced out of certain areas and not other areas, and then measuring the earthworm populations there. So it's pretty much proven. And we've created a lot of edge, and deer are edge species, by fragmenting forests. So if we were to reduce the deer populations back down to the level which the forest evolved with, so deer increase the worms decrease the plants. And because deer eat plants, the deer to plant ratio is higher, and the deer are more likely to finish off all the remaining plants. And you get some of these woodlands that don't have anything on the forest floor. It's just bare soil, which is disastrously bad for the whole ecosystem, the adjacent farms, the waterways. It's bad for
everything.
Whereas we've discovered just recently, and we haven't published anything about this yet, but we've discovered in the field in places like Upper Michigan, where they get 20 feet of snow, and there are no deer, that the earthworm invasion fronts are moving much more slowly than if deer are present. So it'll be interesting to see where that research goes. Is it really just the absence of deer? I mean, we have one plot where literally the invasion front hasn't moved in 40 years.
Interesting.
In a sugar maple forest, which should be a nice type of litter for the worms to eat. And they just have not moved. And so if the deer really have an impact that big, we can manage the deer, and that will change the worms. So, and we probably can't directly change the worms that much. We could, but we could put out some type of poison, but it would kill all sorts of other things that belong in the soil.
Yes, the further cascading effects of species loss. Do you think, just as an ecologist, I think about the disappearance of predators and, the deer populations, across the United States, and how the lack of predator species has led to these, people don't realize the way that a high population of deer, you start to see them in neighborhoods, and maybe they don't look as healthy, and that's regrettable, because I think people feel sorry for the deer. But I think that mental state prevents people from thinking about these trophic cascades that have to do with simplification of ecosystems, and where, certain species are able to expand, and then you see it's those unseen cascading effects that really start to add up over time. Is there any research on earthworms related to the reintroduction of predators?
No. So if we get into that, we would probably be the first ones to interrelate predators and earthworms and deer, if we're able to do that. So I have a bunch of permanent plots where all the trees were mapped in remote wilderness areas in Upper Michigan when I was a graduate student, which is now 42 years ago, and others that I helped map the trees 30 some years ago as a postdoc. And we're recensusing the trees there and, looking at the earthworm situation. And we have some sites where the wolves have returned, and we're seeing tree regeneration for the first time, but we have not had time to interrelate the worms and the deer and the wolves yet. But we're working on a proposal to do that research. So that would be the frontier that we hope to pursue.
That's great. So, most of the conversations around these introduced and problematic species, not just worms, but, I live in a place where we have this lovely Himalayan blackberry. And there are countless others. And we tend to demonize them. And even the word, invasive, is kind of ironic, given that most of them arrive here because of European colonization, and just global trade now and all the things. And you've done a lot of, your work is really in disturbance ecology. And that's kind of how I was familiar with your work. Do you think that introduced and these opportunistic species, do you think of them as a new pattern of disturbance, that's very specific to this time of the sort of the human age? And, how do you think about invasive species or introduced species as drivers of evolutionary change?
Yeah, well, it's adding another stress to the ecosystem. So in a multi-stressor context, you had the fragmentation and the change in the fire regime, and then you throw in the earthworms, and then you throw in high deer levels, and then you throw in climate change. And Peter Reich and I actually published a paper about the prairie forest border, and that's 2010, 13 years ago already, where we proposed that climate change could easily move the prairie forest border, which kind of crosses Minnesota from north west to southeast, could move it 300 miles to the north and east. But then you have things like high deer levels, and the deer are also eating the tree seedlings, and the earthworms are causing fewer tree seedlings than you would otherwise have, and poorer growth of the trees by making the soils more droughty and more nutrient poor. And so will this just accelerate the rate at which climate change causes change, at the edge of a biome, at the edge of any biome, actually, where the edge of the temperate and boreal forest, at the edge of any biome, having multiple stressors like high deer populations and earthworm invasion could either accelerate the rate of change or magnify the amount of change that you would expect from climate change. And so, the multiple stressor thing is definitely, you get more and more filters on which species can be successful, and a much better chance of flipping an ecosystem across a tipping point where it just is going to be something, a completely different alternate state. When you have multiple stresses. And we're not all that good. When you have 5 different brand new stresses, we're not all that good, frankly, at predicting the outcome and how they will interact with each other. I mean, the one we published was a review paper, and we hypothesized some interesting things, but there's no way to do an experiment where you combine all those things. So we're not that good at and don't have enough time to do an experiment where you see how the ecosystem responds to 5 different things happening at once.
And our models are, only as good as the information, the historical information that can inform them. And that sort of brings me, to my next question, which is related to some of your older work, which is, can you talk to people about this concept of ecological memory and how information and material within an ecosystem are parts of how ecosystems respond to disturbance, and why it is that when we have these sort of layered stressors on an ecosystem, we get farther and farther away from being able to understand what might come next.
Yeah, well, and ecosystem memory is the ability of the ecosystem to remember what it was before a disturbance. So, for example, in sugar maple forests, the main type of natural disturbance was big windstorms. And periodically a tornado or a thunderstorm with a downburst with 120-mile-an-hour winds could level thousands of acres of forest. But sugar maple forests have about 1 million sugar maple seedlings per acre. And that is the ecosystem memory. And those will now get sunlight, and they will all grow faster. They were down in the shade. Now they're going to get sunlight when the canopy is toppled. The ecosystem can totally remember what it was, and it recovers. If you have the earthworms come in and they wipe out the organic horizon, the maple seed, and then you have high deer populations, you could end up with no sugar maple seedlings there. And the big trees are knocked over. They can't produce seeds now because they're dead. There's no seed bank for sugar maple. There's a seedling bank instead of a seed bank. So its memory is transmitted through the seedlings. And then you have other forest type like jack pine in northern Minnesota, where it's the seeds that are transmitted as the memory. And the cones will not open unless there's a fire. And the trees have 8 or 9 years worth of cones at any given time. So if a fire occurs, there's 8 or 9 years worth of seeds ready to go. And the cones are such good insulators that the seeds are not killed in a forest fire. And the seeds are spread right afterwards. You can have millions of seeds per acre. However, if you switch the disturbance regime from fire to windstorm, and these windstorms didn't occur very often that far north. We're in the boreal forest now in northern Minnesota. So now you have wind, and that knocks all the trees over, and then you get a fire. The cones are down in the flames now, and they're all destroyed. So the adult trees are destroyed. Any seedlings are killed by the fire, and the seeds are killed by the fire, which they weren't before. So the memory is wiped out. And what we're seeing there is we're getting aspen and birch instead of pine as the regeneration in these gigantic blowdowns, like 300,000 or 400,000 acres of forest blew down in 1999. And the parts of that have burned after that event are flipping over to birch and aspen forests. So the memory was wiped out. So every vegetation type has a way of transmitting memory which is in sync with the disturbance regime that it evolved with. And if you subject it to a new disturbance regime, the memory might not be able to be transmitted after the disturbance. And you can have either total erosion of it or gradual erosion of it, or erosion of parts of the memory, so that that some of the species can reproduce afterwards and some can't. So, and then the more things you get, like if you have worms and deer and more big windstorms and more droughts, you're much more likely to totally wipe out the memory than if you just change one thing. And so that's what's going on now. And this is everywhere in the world, because there's all sorts of new stresses on all ecosystems, from the Amazon rainforest to the tundra, where the ecological memory can't necessarily be perpetuated and be in sync with the disturbance regime the way it was before climate change. And then everywhere you're adding impacts of human activities, which can lead to high deer or earthworm invasions. We're getting earthworm invasions now in the southern part of the tundra. And there actually is one or two papers about that in northern Sweden and Finland, and we're hoping to publish a third paper on that soon. And on the tundra, there's a organic mat, that's a couple feet thick. And if the earthworms eat that, it raises the soil temperature underneath by like 10 or 15 degrees, which then causes the permafrost to thaw. So there are potential impacts of earthworm invasion even in the northern part of the boreal and southern part of the tundra. Not to mention plowing the place up and changing the climate and bringing in grazing animals and all the other things that people, oil drilling and, restricting the migration routes of migratory things like the caribou, all these other changes that people are superimposing on top of climate change. So everywhere in the world, we're going to have to deal with this issue of multiple changes, and will it erode the memory and overwhelm the memory of ecosystems?
And we think about building an ever greater sort of resilience debt with all of those things. And I think it's really interesting. I used to fixate on this, where these colonizer species, they oftentimes play that role of invasive species, but they also, when there is no memory left, they are the ones that can start to rebuild substrate, because they're the ones that can germinate under very poor conditions and with very little else to help them along. And so I think it's really fascinating to have this all be sort of brought back to these layers of complexity that take millions, if not billions of years to build, and how the impacts of our activities are measured in, minutes now, and that, we're doing that scale of change in such a protracted amount of time that these resets are becoming more and more the option, kind of for the ecosystem to begin again.
Right. Yeah. Well, this is why scientists have recommended that anywhere from 30 to 50% of the terrestrial surface of the Earth should remain in natural areas. And, the economy will be much more sustainable in the long run if we do that, as opposed to increasing exponentially and then crashing, which is the course that we're on. It'll help blunt the impacts of climate change. The main industries would be renewable energy and restoring native vegetation and habitat would be the two main industries, and would employ huge numbers of people. But it is a different way of looking at things.
We're looking at a lot of sort of reasons to be considering different ways of doing things, I think, and that would be a lovely vision. And to that point, I mean, can you speak a little bit to how farmers who are listening to this and maybe feeling somewhat abashed at having learned all of these things about these worms that we all feel very proud of, I think, at certain times when we're digging up shovels full of our soil, and you see a lot of, night crawler pathways and infiltration pathways. But I think for people in agriculture, if we are thinking in terms of the generations that we hope to, steward our lands toward, how would agroecology or agroforestry fit into a vision of the future that you think could begin a process of healing where agriculture, instead of being a force of negative change, could be a force of positive change?
Yeah, well, I think if we learn to work in sync with natural processes and learning from ecological memory and all the different ways that different vegetation types respond to disturbance, we could probably manage agroecosystems so that they would be in sync with ecological function and be more sustainable from the standpoint of not losing nutrients, not having soil erosion, not giving off carbon to the atmosphere. Take a lot of research to do that because it has to be unique things in every place because ecosystems are all unique. So I think that's a path forward. I think agriculture can be sustainable long term, and I mean thousands or millions of years. It can rebuild the soil. We don't need to have such gigantic acreages in cultivation to feed people because so much food is wasted. So looking at all those things together, I think it can definitely contribute. And as far as agroforestry goes, we have a project in Madagascar.
Yes, it's so cool. Will you talk about that?
Yeah, where it's called Green Again Madagascar. And so basically it's on the east coast of Madagascar, which was originally rainforest. They get upwards of 150 to 200 inches of rain per year. It was mostly deforested. And now a lot of the local people would like to have forest back. They don't really need all that acreage just for growing rice and so on. So we have several nurseries. We have at least 50, at last count that I saw, 58 species of native trees that were growing in these nurseries. And we are restoring acreage that local farmers want to be restored to forest. We have a number, 70 or 80 people employed there. So you need to have local knowledge. I mean, some of these species of trees don't even have a scientific name. They haven't been given a name. We're just calling them what the local people call them. So you have to use local knowledge. You have to plant the right tree in the right place. You need to follow the trees, pull the weeds if necessary. They need some aftercare. You can't just plant 100 million trees in a day and then walk away because so many of them will die. The most important part is the aftercare in the first few years to make sure they get established. And it's local knowledge. It's a different tree in each place everywhere in the world. So that's what people really need to know is that we need millions of people around the world who have this local knowledge about how to work with their local ecosystem. And so Green Again has been very successful at raising money in the United States to spend in Madagascar, because $100,000 of U.S. money buys you $1 million worth of stuff in Madagascar. There's a site called Plant for the Planet, and it's part of the Trillion Tree campaign to reforest those parts of the earth that have a climate that will support forests, but were deforested and are not needed for agriculture, which amounts to over 2 billion acres, which is about the size of the 48 states in the United States. And they have sites all over the world. You can go to the Plant for the Planet website, look at the dots all over the world, and you can zoom in on one and click on it, and it will tell you about that project, show pictures, and you can donate money to that project. And Green Again Madagascar is one of those. Actually, we have 2 or 3 projects there in the east coast of Madagascar that are green again, Madagascar. And you can donate money, but all of the sites throughout the world on the Plant for the Planet website are vetted. They actually do site visits. You have to pay a living wage to your employees. You have to use local tree species. You have to make sure that they're surviving. There has to be the aftercare in the form of weeding around the trees, replacing any that die, watering or pruning, whatever is needed in the local context to make sure the trees are successful. And all of the hundreds of sites around the world are vetted that way by Plant for the Planet. And we were one of the earliest ones, and they actually used some of the things that we developed as the criteria for other places, like having local employees, making sure the local people are part of the vision for what you're doing, like where you're reforesting and so on. It's and in Madagascar, the forest is food. I mean, they do grow rice, and the rice is great, but one thing you can do for dinner in Madagascar is go outside and pick a bunch of things from the nearby trees, and that can be something that you do every day in that climate to get food. And so it provides diversity in food sources. It provides habitat. And of course, we've only been doing this for 10 years, but as the forests mature, it'll be interesting to see if any of the lemurs move in, because they'll be the ultimate judge of whether our restorations are successful. I mean, if lemurs which are unique to Madagascar and aren't found anywhere else, if they consider it to be good habitat, that means we did a good job.
Yes. Let nature be the judge. I'm so glad you brought up Plant for the Planet, because the Madagascar project, which can be accessed via your site, and we'll link to all of this, being one of those. I mean, when people ask me what I think of, these, like, let's say the hotel that you're staying at gives, for every $1 that you spend, they give 2 cents to this reforestation project. And when people ask me if there are any projects that I recommend, Plant for the Planet is the one that I feel best about, because it is verified, it is ecologically fluent in terms of what's appropriate in which ecosystem, and just the social implications of retaining what knowledge we can from the people who have coexisted and co-evolved and survived for, in many cases, thousands and thousands of years in these forest ecosystems. So I highly encourage all of our listeners to check that out and support your work there as well. And you've been so generous with your time. So I'm going to let us wrap up here, but I just, want to give you an opportunity to, share any final thoughts or anything else that you'd like for people to be thoughtful about, or especially our listenership who tend to be food producers, more ecologically minded. Any final thoughts for those people?
Okay, let me go back to Darwin. Mm-hmm. Darwin wrote a book about earthworms. It was the last thing he published before he died. It came like 20 years after Origin of the Species, and a lot of people don't even know he did a bunch of research on earthworms, and he thought that they were the most influential species group on the planet. And the way that these invasive earthworms transform ecosystems, I'd say he's right about that. And over tens of millions of years, they've determined the chemistry of the soil and what plants grow there, and through that, the chemistry of the atmosphere. So they really do run the world. But we need to learn a lot more about them and what they do as invasive species and how they interact with crops in different places around the world, because it's going to be a lot of unique impacts. It's a real frontier of knowledge. Earthworms are incredibly important They influence everything from what plant will grow in a certain place to the climate of the earth over hundreds of millions of years. We need to learn a lot more about them. There's so much we don't know about these invasive earthworms in natural and in agricultural vegetation. I wish I could have said a lot more than I did, but it's very much the leading edge of the frontier of knowledge. And we're going to have to learn a lot more about earthworms very quickly here if we want to manage the planet correctly and manage individual acres everywhere in a good way.
Yes. Well, I'm delighted to hear that you would love to say more, because perhaps if you would agree to come back and have another interview with me, we could go 2 levels deeper into some of these. I agree with you. It's so challenging to talk about ecological principles in even 90 minutes, and to convey the ways that things are so interconnected, and how things that we think are just locally influential can impact the climate, and the atmospheric chemistry, all the things. So it would be wonderful to have you back if you had the appetite for that.
Yeah, it'd be good to do that sometime. Yeah.
Awesome. Well, Dr. Frelich, thank you so much for your time. And we will link to your website. And I have a couple of my favorite papers and your book that I will definitely link to. And we will make people aware of your project in Madagascar. And as anything else we can follow, we will definitely do that. And I wish you the best of luck with your, getting all of your projects funded. And if any of our farmers want to volunteer their field soil for worm research, we'll definitely know who to reach out to first.
Okay, it's been fun. So thanks for having me on the podcast.
So I think we can all agree that Dr. Frelich is such a great interview. And so great that I would love to have him back, as I threatened. And hopefully he'll agree to come back at another time if you guys are into it, because I think these ecological topics, I think that I try to shoehorn in occasionally, they really do have broad implications and applications for what we all do every day. And I'm so stoked that he brought up the Darwin book, because for my wrap up here, I was going to actually use a little quote from said book, The Formation of Vegetable Mold Through the Action of Worms with Observations on Their Habitat by Charles Darwin.
When we behold a wide, turf-covered expanse, we should remember that its smoothness, on which so much of its beauty depends, is mainly due to all the inequalities having been slowly leveled by worms. It is a marvelous reflection that the whole of the superficial mold over any such expanse has passed and will again every few years through the bodies of worms. The plow is one of the most ancient and most valuable of man's inventions, but long before he existed, the land was in fact regularly plowed, and still continues to be thus plowed by earthworms. It may be doubted whether there are many other animals which have played so important a part in the history of the world as have these lowly, organized creatures.
Well, far be it from me to take any umbrage with the great Charles Darwin, but I think we can all benefit from a little perspective shift, or at least some new thoughts about the impacts of how some of these plow-like interventions have caused changes around us, and see the world every day in a new light. See you next time.
right. I hope you enjoyed that episode as much as we did. Real quick, some things that we have going on. The YouTube channel is still cruising, and we did a whole series of farm tours this summer shot by Jackson, featuring several different growers who have been already featured on this podcast, such as Asawaga Farm and Frith Farm and Four Winds Farm, plus interviews with two of our podcast hosts at their places. That's Jane Murner of The Composter and Clara Coleman of the Winter Growers podcast. So go check those out at YouTube. Just search for No-Till Growers. Also, here are a few places you can find me this winter of 2023-2024. The Acres Eco Ag Conference just across the river from Cincinnati. I will be doing a full day session there for the Eco Ag U, which you can and should sign up for. I will also be there all week hanging out, so check that event out. There is also the 2024 Dallas Inner City Growers Symposium in Texas, the Utah Food and Farm Conference at the Red Acre Center in Utah. This is as far west as I will go this year, I think, so make sure to catch me there. Of course, as always, I will be at the Organic Association of Kentucky Conference here like 15 minutes from where I am right now, and the Organic Grower School outside of Asheville, North Carolina. All the links for those are in the show notes, and also linked in the show notes is an important survey we would love for you to please go fill out. That survey will just help us to know how we're doing, and if there are any content areas that we are missing. We will pretty much cover anything and everything farm related, so let us know. And the reason we're able to do all that is because we get so much support from you all. You can show said support by picking up a copy of the Living Soil Handbook or a hat or some merch at no-tillgrowers.com. Or you can join the hundreds of donors who support us through patreon.com/no-tillgrowers. That is the absolute lifeblood of our work, and at a certain level, or if you just bump up from one level to another, you get a shout out on the show. So big shout outs this week to Abraham, Chris Yates, Closter Farm and Livestock Co., Sean at All About the Garden, and Stephen Smith. Huge shout out to everyone who supports us in whatever way that you can. You all are amazing. Otherwise, thanks for listening. We'll catch you next week. Bye.